Hey guys, my name is Alex. Hey guys, my name is Alex and thank you very much for stopping by. Really appreciate your visit. And today I want to solve the previous problem, the Fibonacci sequence recursively. Yes, that's really great. That's a really great way to solve problems. And Fibonacci Factorial and a lot of amazing problems are great to solve with recursion. So without further ado, let's get into it. Well, as usual, as you can see, I'm using this Ruby Online compiler, which is this online IDE, so you don't need to have a Ruby environment in your local machine. If you're new here, this is the way that I'm doing this, and I'm sharing the link in the comment below. So the first step that I want to take is I want to create the method that will be called Factorial, Fibonacci, Factorial. Fibonacci, and then it takes an argument, which in this case will be the count. That's the same thing that we've done previously, and now we have this puts Fibonacci, and here you go. I'm going to calculate the Fibonacci of 8. Perfect, which in this case will be the number 8 of this the sequence. Just a reminder, this is the Fibonacci sequence. I'm going to start with 0 and 1, which in this case are the numbers previously defined in this Fibonacci sequence. And now the next number will be 2, which is the sum of the previous two numbers, and then the 3, which will be the sum of the previous two numbers, and 5, which is 3 plus 2, 8, which is 5 plus 3, and 13, and 21, and 34, and 55, and 88. That's it. That's perfect. You know, it starts at 0. The index itself for the array starts at 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and you can go, and that's it. That's it. Oh, actually, you have one more here, right? 0 plus 1 is 1, and 1 plus 1 is 2. Here we go. So the number that I'm interested in here is 0, 1, 2, 3, 4, 5, 6, 7, 8. So the answer should be 21. That's it. So I'm going to calculate that. The first thing that I want to tell you is that I don't want to go, I don't want to explore what recursion is, because first of all, we had done that before in the factorial version, the factorial video. And to be honest, I think that this is a big, not complex, but big topic. And I'm kind of planning a few videos just exploring a few problems that we can solve with recursion and all of the drawbacks that you have when you choose to use recursion. Yes, because life is not perfect. And then I just want to go straight to the solution, because this is a very straightforward solution. So the first thing that I want to do is I want to say that if count is greater than is less than or equal to 1, then I want to return count. That's it, because that's the same logic that we have done previously. And then you can just say if count is less than 1, return count. Else, what you can do, you can just return, yes, this is the moment that where you call the function itself, which in this case is a method, and you can just say, hey, if I want to calculate, for example, 5, I want to sum 3 to 2. But the reality is that I have to calculate the Fibonacci of 3 and Fibonacci of 2, which in this case, I'm gonna say Fibonacci. I just want to sum the Fibonacci of the number, the previous number, with the Fibonacci of the count minus 2, which in this case, let's say that we are here, 8. You want to calculate with 8 with 5, which in this case is count minus 1, and with 3, which in this case is count minus 2. You are just moving into the number that you are interested in. And that's it. So that's the solution. Let me just check if it works. If you execute this code, let me see. And here you go, you have 21. Let's say that I want to calculate 7. It should be 8 is 21, so 7 will be 13. And if you execute this code, and yes, here you go, you have 13. So it's working and it's totally fine. What I want to do, the next step is actually this code can be a little bit better. You know, I want to write this code in one line. And it will be great to have this code in one line. So I want to say that this will be called another method that will be called Fibonacci 2, and essentially it will take a count as an argument, and that's it. What I want to do is I want to say, hey, Ruby, if the count number is less than or equal to 1, this is a question, please return the number itself, return the count itself, which is the same thing that we are doing here. Otherwise, I'm going to return exactly like this. And here you go, you have the Fibonacci sequence in only one line. And if you execute this again, it should be 13, and yes, it's working. So that's a good way, great way to solve this problem with recursion. You can do the same thing with Python, with Java, with a lot of different languages. And I hope that you like it, and see you in the next video.